So just a little bit of background on this one. We recently formed a networking group. So this is there's a set of first things we really ought to think about doing in networking land. So we organised a set of sessions which are the set of key things that the networking group wants to start looking at. And this session is all about real-time, which is mostly preempt RT. So the point is to have a discussion which says, okay, how do we bring preempt RT or other technologies into Linaro? How do we test them? How does that fit with some of the other work we're doing? What's the best thing? So if you look in the actual session, there's a bunch of notes about this which come out of the set of meetings that we all had. But if you want to contribute at all, please come forwards. Otherwise, it's going to be a very dull conversation with me and Deepak. And I'm also going to attempt to take notes and run a meeting, which is never a good idea.
Well, if someone wants to volunteer, take notes for us. Great.
No, I'll be nailing. Okay. So, what kernel version of the latest preempt RT patch is that?
John, do you know? What has
Off the top of my head, I think it's
not the latest.
yeah, I think it's like 3.5 or something.
Yeah.
It's like a couple back.
Yeah, so the preempt RT stuff tends to be several versions back, and for a while it hadn't gotten updated for many versions, but I think so 3.5 you're thinking. 3.5 is 3.6 or something around there. So probably the first step we want to do is basically have someone within Linaro, within the kernel working group, within LNG, reach out to Thomas and sort of say, hey, we're going to start poking at the preempt RT patches again on ARM, because for a while there were other people sort of testing preempt RT on ARM. I don't think anyone's actually been doing that the last couple of years, as there hasn't been as much interest in that. So that'll be sort of the first step, is bring that in, start testing it, put it into our CI loop most likely, and just start beating on it and kind of see what issues we find. Since we're going to be wanting to test on A15, actually probably the first step is going to be to basically work with Thomas and whoever else upstream to move the whole RT patch set to TIP. So that's actually probably the first priority before anything else.
He may not be into that.
He may not be into that, but
I mean, so part of the history was that they spent a lot of time trying to get it into Git, and Thomas got very frustrated with that workflow, and so he went back to using Quilt, basically.
Yeah, right. They still use stack of patches.
And so it just doesn't get updated. Oh, I'm sorry. Basically,
you're going to have to go. Sorry.
I don't even know what the use case is. I guess so. A number of years ago, I worked with the RT patch set, and they'd put a lot of work trying to get it into a Git workflow where they tried to keep it up to date and kind of move it along. But that Thomas just found to be a pain, basically, to constantly kind of try to move things forward that way. So he kind of fell back to using Quilt and doing things a little less regularly, just in order to kind of really harden things up. There's so much churn sometimes in the patch set at kind of a deep level that it sometimes takes a while to stabilize back every time they rebase. So I think it's the constant update was just something that was too painful. So
go on.
But painful or not, I think it has to.
Yeah, because
we need UMM, we need LPA, we need the chip support that the members are using.
Right.
It's not that old. I mean, it tracks stable. It's 3.6 something or other. It's not that bad. It has all the support.
It has all those things in it. Okay.
I think trying to rebase this on tip is just a cause for one in the front.
So don't cause yourself work.
Yeah. Well, the challenge is going to be some of the silicon we're going to see for the networking products. So now we've got two stories now. We've got, well, we want your SoC ports to be on the latest kernel, but if you want RT now, well, we actually don't want it on the latest kernel, we want it on the sole kernel. So most likely, yes.
So if you've got stable, you almost certainly got preempt RT patches there.
Okay.
Yeah, but these products aren't going to ship for a year and
Well, I think, and the point that Will's making is, you know, most of the work in Linaro, we're tracking the tip. We're pretty close to the front, and that's great because we want to put stuff up there. But preempt RT is mostly, it supports more than the stable releases, but it's a release behind roughly. And as someone else said, it's all the architectural features are there, so it's complete. It's not, you know. So we got choice here. Either we try and pull preempt RT into tip and push it all up and make it all wonderful and da-da, or we follow what they're doing and use the sort of one kernel version behind, or even just the stable releases. So fine, that's great. That works for networking.
I mean, you wouldn't do your all bring up preempt RT kernel.
Right.
It's just a stupid thing to do. So you do your all bring up, and if you want preempt RT, then you can run it doing that. But I don't see the benefit of doing everything in one big tree.
So you're saying,
So,
go on. Ola?
Do we want all of preempt RT? And what's the drawbacks of getting all of it?
So I think that sort of leads to what John was asking me, which is like, what's the use case specifically for networking?
but I think taking parts piecemeal is an even bigger mess than saying move it all to a given release, right?
Sometimes it's even just config-wise. I mean, yeah, piecemeal at the patch level might be a bigger pain as well. I do know that you can, you know, scale some of the config options up and down for things that you want. Usually, the sleeping spin locks is kind of the biggest impact change, both on latency and performance. And so that's kind of the big trade-off knob. But I don't know. I guess I'm kind of curious. It's one of these things. It's been a little while since I've done anything with preempt RT. As far as one of the issues that we're running into it when we were trying to do, you know, enterprise real time, was that for a lot of the CPU-bound work, it was fine. Didn't see a big performance impact. But when we started to go into I/O, that's when we started to see a lot of pain. And I was curious, kind of as far as how much toying around have folks already done with this for their kind of network usage? And I'm just kind of curious more about where people kind of, what experiences people have had and where their pain points are with it, and kind of what they want to see, or what they want to get out of it in particular.
I guess I'm not convinced the end customers know yet.
Okay.
It's, boy, this RT stuff looks like we need to have it, and until we can show them that it's there and they start using their use cases, they're not going to tell us why do they feel they need it. So there are one example I know, there's a networking vendor that does base station work, and they have very tight deadlines for certain in the microseconds, deadlines for certain parts of the workload.
So we run laser welding robots with 3D floating point math and user space without preempt RT on commodity Intel hardware very easily. And I would really, really push back on this. Almost nobody. I've seen it, I have yet to see, I don't think I've found one valid application, and that was with work with John. That was about the only place I could see justified. Because the whole stack, from the bottom to the top, is custom support. A lot of these networking guys are running Java user space, and they're not touching their code. Yeah. They're running legacy C code, and they're not touching their code, and preempt RT does not help. They think it does, but it really doesn't. I mean, the IBM, learn from IBM's experience. Please.
So your argument is, you know, Google's self-driving car does not have a real-time operating system in it. It's standard Linux.
It does.
It's not needed.
Well, no, I mean, it's a standard thing, isn't it?
For the Linux part.
Yeah.
But they have a separate control system
Okay.
that is real time. Right? So they solved it by segmenting the problem into real time and not real time.
Think laser welding robot?
But does that work because you're throwing CPU at the problem?
Of course. But you have to pick the right hardware. You have to. I mean, otherwise
Yeah, I know one complicated part as well that we ran into as far as kind of the warnings that might need to be taken with this is that it took a lot of very careful tinkering with priority levels across the system. And you have this whole aspect of like, you know, a SCSI controller can only not, like, you know, the heartbeat for that needs to happen every so often. And so if you have a high priority, you know, RT task that's keeping the CPU busy and blocking out now the IRQ that triggers the watchdog that makes all of a sudden the SCSI controller goes offline and you can lose your disks. And so there's sort of this weird aspect of like, we really are putting kernel functionality at a lower priority than, you know, userland code. And so you have to be very careful about kind of these fuzzy limits of how long you can really just defer that kernel work. And I don't know, there's a lot of gotchas like that, so people end up playing around with, okay, so the networking has to be at this priority, you know, the next networking hierarchy has to be at this priority, and the SCSI hierarchy has to be at this priority, and then as long as any, you know, RT apps don't really run at prio 99 for longer than, you know, a very, very, very short amount of time, then we're okay. But it's a lot more of a tinkering, custom sort of setup, and so for people to think that it's just going to work and it's a magic flag is definitely not the case.
Well, I think most of these guys are coming from RTOS environments, so they're very used to tinkering.
Okay.
I think the education is trying to educate them that, by the way, you don't need to tinker on everything.
Okay.
And I think the use case is, I have a job that's 10 to 20% of the CPU that has very hard deadlines. And I want to use the other 80% of the CPU, best effort, I want to get as much throughput as possible in the other 80%, but I can't miss my deadline in the 20%.
I would like to add one observation here is that I'm pretty sure all these systems will be multiple systems, and different cores will have different real-time requirements. Like none at all or very strict. And maybe perhaps RT, if you take the whole patch, you get the same kind of real-time characteristics everywhere. That's not necessarily what you need. So, with regard to this starvation issues, because you run your application on a high priority, that wouldn't be, if you could keep the normal kernel on some cores.
Yeah, that's another complicated approach to go with too. But at the same time, you can use CPU isolation and basically saying, okay, well, you know, we run all of the kernel threads basically run on one CPU, and we're able to make sure. And that works to some extent. There are some per CPU threads that you just can't migrate. But that's a good approach for at least some of it.
Actually, that's being worked on. You guys are solving that problem. So, a lot of the time it's just, here, have a CPU. Don't blah, blah, blah.
Yeah. So that's something I haven't worked on recently. So.
So, I mean, the discussion, as it's come around a little bit, is why are you using real-time patches? Why not just solve this problem a different way?
Well, if that's the answer, and we think that is the answer, then we need people that can back up that answer with one-on-one conversations with these customers that think they need it, because you know, just saying, by the way, you don't need that is never a recipe.
No, I've got the impression of a immovable object and irresistible force, i.e. there's a bunch of people saying we use real-time stuff and therefore we need real-time, and another bunch of people going, yeah, not necessarily, solve the problem this way. So what I'm interested in is how do you match those people up to have a sensible conversation? The result, the end result has to be good products that actually work. And I'd rather not go off and do a bunch of preempt RT stuff. I don't have to.
Well,
we would. But,
there are two
but how do you
end users in LNG that suggest that we start communicating to them.
Okay. So I think, I'm not sure we could solve it in this meeting, but I think we should have a serious look at the actual use cases and whether preempt RT is necessary, and if subsetting preempt RT. And,
I can see there's cases where it's useful. I just definitely do want to make sure that it's well applied. So.
Yeah. No, okay. So I'm just writing an action which is let's set up a discussion in the networking group that is about for these use cases, preempt RT may or may not make sense. Let's think about, actually it's analogous to the enterprise where you start thinking about verticals, particularly use sets, where you need to fix hip hop in this one, and so I think we need to think a little bit like that. But to circle back, let's sort of ignore that, because I don't think we can do that in this meeting. But
well, and likewise, I don't think in this meeting we can come up with the correct answer to up-port or back-port, because we don't know what are the absolute requirements for the silicon vendors.
Mm-hmm.
How much stuff. I mean, we need it. We need the latest LCA fixes for our hardware. So we could backport those.
my belief is that I looked at preempt RT a couple of months ago, and it's got all the right latest bits in that I could find.
No, I think that regards to latency, it does depend on the use case. You need to find out what you people are trying to do. So, as Craig said, you can't replace hardware that's one or two task by switching to preempt RT. From my experience with it, it decreases best case latency, and it decreases average case latency. Your worst case latency is still going to be out there. And if that doesn't meet what you want, then don't win. So it really depends on the use case. If there's a hard deadline, you absolutely can't miss it, otherwise the plane falls out of the sky. Preempt RT is not the solution.
So my working assumption is that the latest release of preempt RT is pretty close to TIP in terms of versioning and has all the architectural features. That's my understanding. So I don't think there's a job of work to add more features. I think it's more about interactions with other part of the systems and characterizing performance. I just want to go back a little bit to the how do we progress. So Thomas, as you say, is not trying to stay with the tip. He's a little bit behind. He's got a set of patches, and he's moving at a reasonable rate. There's not too much of an issue. So, in terms of trying to pull that code base into Linaro, put it on some hardware, and start testing things, I think the statement from Will was, don't spend your time porting that forwards to the latest stuff that Linaro, if Linaro happens to be building this latest thing over here, don't spend your time pulling it to that. So what we need to do is build the Thomas Gleichner version.
Right, so my thought is it sounds like there's parallel efforts we need to be doing at the same time. One effort is we need to go talk to the end users and kind of really understand what do they want, and does preempt RT actually solve that problem. And as we're doing that effort, we may want to just try basically running the RT kernel in a CI loop, just doing some basic testing on it. Because the thing we'll have to figure out is at some point we're going to have to make a decision. Let's say the products we care about and the members that you're going to be using these products, they're not going to be out the door, like you're saying, for let's say another year and a half, 2 years, maybe even longer. We're going to have to make a decision at some point. Do we go with the version of preempt RT that's out in the community? Do we take hardware support and backport it? One of the things we're not talking about in this room right now is 64-bit. Preempt RT on V8, is that a requirement for any of our customers right now? Will it be a requirement in a year or two? So those are some of the questions I think we need to look into deeper also.
Well, my reading so far of the conversation I've had with networking land is let's do 32-bit now. 64-bit interesting, but it's kind of like 5% interesting. It's not okay. The other proof point though, Thomas Gleichner, that code base exists because there must be some use cases. Thomas doesn't do work for nothing. Ooh, scary. So Thomas doesn't write code for no reason. Even if someone paid him to do it, he wouldn't do it unless he thought it was useful, right? So it's a sort of a proof by existence thing. We should. So I think one of the next steps is to bring that code base in, the latest, figure out which hardware support is nearest to it, and port those two bits together.
Another thing that I don't know if
it will have as much of an implication, but we had to be very careful with the hardware we selected, at least on the enterprise side, because a lot of the stuff that was, fun stuff like SMIs, which would basically cause this, OS invisible latency, basically. And as ARM sort of adapts more enterprise-y sort of things, I don't know how much of that stuff's coming down the pipe with UFI and ACPI or whatever. And so that may be another thing that, to watch out as far as kind of the scope of, if people want to go down that path, we also need to make sure that they're careful about the platform as a whole.
So luckily, we don't have very rich firmware at this point.
Yeah.
And what we do is all open.
Okay.
So what choices do we have in reasonable hardware at the moment that we could make some useful use of? In terms
Bristol?
Yeah, okay.
It's probably the best choice for now.
I'm sorry, which one?
Bristol?
Crystal.
Yeah, the ARM's versatile platform.
Bristol Versatile.
What, as in A15? Or
Yeah, the A15.
do we have enough of those in the rack to?
That I don't know. That's I'd have to go ask the QA and build services people.
I can't remember if I saw versatile platform support in Thomas's code.
It should be there. Yeah, if A15 is there, then it should be there. If not, it's probably a small set tweak. I mean, backporting SoC support is fairly simple for me to do. It's more of a challenge if we want to backport, like, let's say down the road we want to backport full CPU, we want to backport V8 to an old kernel version. That's probably a bigger challenge than just saying backporting the single SoC version.
Okay. So
Irondale is another.
yeah, Arndale.
Although for networking,
Yeah.
Dale's not great.
Right.
No, you're not going to get a really realistic network product-like thing. I think you get some code in, build it, and ensure it runs some tests and see how it interacts.
Yeah.
For the initial go, I think that's.
Yeah.
The first step is really just beating on it. We have a preempt RT kernel, and we beat on it and see what happens.
What about tools, like latency top and things like that? What is the status of that on ARM?
I don't know
Just work?
of latency. I don't know about latency top. Do you know, Will? Okay.
The cyclic test and the RT test I just wrote.
Okay.
And that does just work.
Okay.
So what are the sorry, I'm trying to take notes. What are the tools list?
So the cyclic test and RT.
It's
RT.
part RT test.
Yeah, basically the RT test stuff all works. Latency top we're not sure about, and we can take an action to look at that.
And what sort of above the kernel? What sort of thing do we need? Just a basic
Basic userland, little engineering builds.
open embedded?
Yes.
RT Android. Okay, we'll put RT. Android.
RT big little Android.
Yeah, right. So open embedded.
Yeah.
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 Is there a minimal build of that? Not. I know there's a lamp stack stuff, but is there a kind of a smaller?
I think that's
version?
part of what the engineering builds are, but I didn't get a chance to go to that talk to really understand the full scope of it. So that's the.
That's the V8 stuff,
Yeah.
right? I mean, just the
No, we're building open embedded for V7 and V8.
Yeah.
Yeah, I mean.
We had to do the V7 work to get the
Core
V8.
has a minimal.
Okay.
Yeah.
And the Yocto and OE core supports RT for x86, so it probably already has the recipes for the tools and the tests and stuff.
So I think what we've just said is take the latest version of preempt RT, backport hardware support for Arndale, stroke versatile into it, start beating on it. We've got some test tools, and the system we're going to use is the minimal open embedded.
Which platform is this?
Well, the
So we
suggestion is Arndale and versatile are the two. We can do anything.
Right.
Run them in threads. Wow, great.
Yeah.
Try and do any IO latency.
Yeah.
Got any better suggestions?
Well, in a couple months, Tiago will have a platform.
Right now, those are kind of only options. Does the Arndale have PCI Express?
Not in a way you can get out of it.
Okay. In terms of plugging a network adapter, just want to do some basic testing. Okay.
Stuff like the latest trace stuff in the trace version. That's just things to make sure that the
Latency
existing kernel
trace.
debugging tools work.
So it sounds like if you pull it all together, make sure the tools work, then what we're doing is being ready for that better piece of hardware where we can actually find something useful out. Don't try and do anything that's measuring anything. It's just assembling all the bits in one place and going,
CPU-centric.
great, we've got all
Not
the
the
bits.
IOs.
Okay, all right, that's
And I
makes
mean,
a lot of
something
sense.
also think about is that I think, there'll be a new stable kernel out later this year. So start just pinging sort of Greg and saying, are you planning on, not Greg, Arnd, not,
some random person.
Pinging Thomas and basically saying, hey, are you going to be moving to the stable? If not, can we sort of help you with this or sort of, be the ones who move forward with that? So at least a newer kernel, and so when we do newer hardware support, we don't have to backport that far back.
So make ourselves known to Tom, Mr. Gleixner and
Again,
to say we're
yes.
starting to do, again. It's always nice. And so
Invite
we're
him to
doing
next-
this, we're starting to be involved. Anything useful we can do while we're doing this.
Yes, invite Thomas to the next Connect.
I invite Thomas to every Connect. I just can't get him to
Well,
travel
this
when
one's
it's
a
20
lot
miles.
closer. The next one's a lot closer.
Remember the one we had about 20 miles from where he lives? He still didn't come. Well, actually, he came to the town to go out for beer with people, but he didn't come to Connect. Anyway, so yeah, there's another bit which is let's talk to Thomas. But the first part is to pull all these bits together, make sure the basics actually work, and then think about what platform we can actually put up. Don't do any fancy-dancy looking at deadlines and I/O. That's useless, right? Don't let's get carried away.
It boots, it runs.
So there's another patch set that's interesting, or was brought up, both actually. No Hertz full. Does anyone have knowledge of that one? Just
But it's also interesting for power. That's the extent of my knowledge. Find Kevin Hillman.
Okay, so this is Frederick's,
Yeah, it's dynamic ticks.
but more than just dynamic ticks, it's the dynamic ticks when we're in runtime rather than idle. And so this is basically something that usually you're able to just disable the tick so that you don't get the regular scheduler tick while your task is running. So basically, it simplifies, it reduces overhead and doesn't thrash a cache. Usually it's useful in high performance computing. So I'm not sure if it's,
So, this is already being worked in the Linaro power management group, right?
so there's the no hertz that is already upstream.
Yeah.
And that basically is where, if we're idle, we're able to turn off the tick on the CPU.
Right.
This is basically allowing that, there's some other work that's currently in development that's usually close to the RT work.
And, yeah, and the context I heard for power management was, if the only thing, your core is almost completely idle, except it's periodically waking up to do some overhead management kind of things, move those all to one core so that all the rest of the cores can power down.
Maybe it's slightly different than.
Yeah, I mean, so the case where they like it for real time was there was a bunch of folks, I think, in high frequency trading basically, that were doing some really goofy stuff where they were offlining CPUs and then giving those offline CPUs tasks so that they didn't have any overhead. So they were basically tight, CPU bound work. And Friedrich's work, I believe, basically is trying to get that same sort of functionality, but without having to offline the CPU and have a separate, task scheduler basically doing
What's
this.
the name of the
That's
chap doing the
exactly
work?
the use case that's good for power management too, because instead of giving it a task, you can give it the idle task, and it can just stay idle, right?
Okay. I guess my understanding was with idle, you get that mostly, or people just offline the CPU at
There was
worst.
some, I think, yeah, you're right. It was the case where there was one useful task on that CPU.
Oh.
But even that's useful for it's good for throughput, it's good for real time, it's good for power management.
So who's the guy working that patch?
Friedrich, I don't know his last name clearly. It's something with a W. Weiss. Okay.
Can you spell that out? I'm terrible at names.
WEISGKE.
Okay, yeah, I've seen what I've written there. So yeah. Good, thanks. Let's reach out. So that's the other patch set to bring in. That's the one we
to consider, but
Yeah, it's associated with the Darcy callback, offlining, and all that sort of stuff. It's all kind of tied to this.
well, yeah, it causes a lot of complications and breaks a lot of assumptions in all sorts of code. So it's been kind of out of tree and progressing for a number of years.
I think it's nice to have, good to have, and I don't think it's critical for either of these cases.
I mean, I guess if you have a situation where you really have a CPU-bound task that's doing something that's handling network packets or something like that, where packets are just given to it in memory,
So
you might have a situation where even taking the timer tick, because you're not going to run anything else on that core, basically. That could be a useful case.
But I think it's like getting back 5% or something.
Yeah, I mean, it's
so it doesn't make any sense to you need to understand the use case you're trying to solve
very much
with this patch set. So
yeah,
it's
and it adds a lot of complexity.
yeah.
Just
So don't randomly pull it into a code base and go done.
Yeah.
'Cause that's not true. So it sounds like, I mean, the first job of work is to assemble the bits for preempt RT so that we're ready. We know the tools work. It's kind of, does everything work? Are we all here? No Hertz full looks like add it to the queue and think about it, but don't do that first, right? What I'm trying to get out of this is actually, if we ask some engineers to do some work, what's the sensible set of things to ask them to do? That's what I'm trying to.
the other thing is, I think getting a good sense of the use case is really important, because there's, I think, aspects with all of this work that is unfinished, and so, there could be a lot of larger work if people are wanting, improvements on those for certain use cases. Some of the I had a big to-do list as far as real-time way back in the day, as things that needed to get fixed that just are still problematic.
So earlier on, I noted an action about discussion of use cases. So, and this has come out as a thread several times in this conversation. We need to go ahead and go, what are the use cases? What do we want to try? What hardware do we need to test those, and software setups do we need to test those use cases?
But it's go beyond just that.
Oh, cool. Yeah. It's not throwing code together and go done, right? So yeah. But it's the whole use case, sort of quite validation, but benchmarking. There seems to be two phases. One is, do the basic bits work?
Mm-hmm.
Have you got some sort of CI loop, some sort of where you're ready to then start exploring these use cases and things? Okay. So I think that's the two initial things to do. So just let me summarize. There'll be a coffee break shortly, so I want to keep this one fairly short. What I think we should do, if we've got some engineers, is take the preempt RT patch version that's out there, the latest one, backport hardware support into it, Versatile or Arndale. Pull that into a minimum open embedded build. Check that the tools work, the RT test stuff works, latency top, latency track. Start just pulling together a list of tools. Does it basically work? Does it build? Does it run? And in parallel with that, start talking to Thomas and say, Thomas, what makes sense? How do we support what you're doing? And the other parallel activity is to start looking carefully at use cases and why trying to solve the problem of the sort of real-time response or the latency, whatever you're critical, that might be supported by this code base. And then maybe that'll build out to building test rigs with those use cases so that you can check that the solution you're suggesting actually works. Yeah.
And I think as we look into the use case, so we'll find out sort of what are the RT patch set has the set of features, what are the specific features that our end users most care about, and we can sort of focus on those and improving those.
Who in Linaro or associated with Linaro or not in who can help us with those kind of use case and thought processes?
You guys?
this guy over there.
I
We said,
said
okay,
one.
well, I mean, I'm assuming somewhere in the Linaro networking group there's
Yeah.
some knowledge here, otherwise we're stuffed. But I'm just wondering who else around Linaro and the community, other than Thomas, obviously, can help. So it'd be good to get a list of names. Okay. So I'm not proposing to do any more. I think I've got a better idea of some logical next steps. And I thanks Greg as well for saying, guys, challenging the assumption of just go do this with the code. Thank you.
Remember, make sure you put laser wielding robots in the notes.
Oh, laser wielding robots. Yes, sorry. Yeah. I didn't get laser wielding.
Welding, not wielding.
Oh,
It's your accent, dear boy. I can't always understand it. All right, so I think that's it. I think we break for coffee. Thank you very much for help. And this isn't an ideal room to have a discussion. Okay, so great. Go have coffee.
Just one other thing, Dave. In the Kickstarter document, there was talk about a couple of feature-related things. So do you think we just need to table that for now, or
Which release? Which were those? Sorry.
the high mem?
Oh, okay.
Yeah, I mean, those are separate than this discussion. I mean, they're not separate than the real-time discussion.
Well, I think if we pull the code base in and check for the features.
So this is HIMEM?
Yeah, well, Hyman was next.
That's not RT support,
No.
yeah, it's just generic.
Is that the combination of RT and LPAE, which I was
RT, I mean, LPA and RT, I mean, it shouldn't matter if
Shouldn't.
it's LPAE or, it should, yeah. I don't see why it would matter, but.
How many season change?
Right.
So, features like large physical address extension, that's just hygiene. It's not.
There was two things that were, two feature-related things that
Huge
were.
pages, isn't that
Those were yours, Magnus, right?
Yeah, huge pages and HIMEM were the two.
the transparent huge pages, I think, is disabled.
Okay. It's disabled the RT patch?
Yeah, the RT patch disables.
Okay. Okay, so try to find out why does it disable it. I don't see why it would. Say it?
Something predictable, so it makes sense to disable it and actually just allocate directly huge pages statically.
Right. Instead of,
Otherwise, your transparent huge pages can be fragmented at any point in time.
so it adds a lot of unknown latencies.
TLPs are all over the place.
That makes sense.
I think this is one result of the working with the parameter patch set is to compile a list of these side effects that might not be desirable, or even
Okay.
if they make sense, to know that you have these effects.
So now just get the patches in and then figure out there's the list of these are the side effects and they're good reasons for these. Da-da-da. So just
So you know that they changed the default behavior.
Yeah.
and don't just blindly thrash around fixing things that don't need fixing around.
Yeah, so it's kind of doing a one-level sort of deeper analysis of the RT. Look at the patches themselves, not just bringing them and kind of look at them and see, okay, what areas do the kernel actually touch, and how might this
Okay,
affect?
yeah. So given some engineers, bring the patches in, put them in there,
Yeah.
list the side effects, think which ones are just things that have features that haven't been implemented that they're useful or might be useful. And okay, good. I've got the action now. Yeah, good point. Thanks, Bob.
Just for the record, I assume that the RT and the digital switcher are incompatible.
Yes, given. Agreed.
Okay, all right. I think we've used time wisely. We've moved forward, so I don't wish to waste time, and I do need coffee.
Thank you.
So thanks very much, guys.